Hey guys, welcome to Digital Srini channel on YouTube, and this would be a great time to pause the video and hit the subscribe button and continue. Okay, here I'm going to talk about decorators, and if you already know what decorators are in Python, then probably you won't gain much from watching this video, but you never know. Please keep watching. If you don't know what decorators are, of course you're at the right place, and I am going to talk a little bit about functions. We'll appreciate exactly the various behaviors of functions, and then we'll go into decorators. And in summary, decorators will help us save a lot of time, especially if you are planning on doing certain tasks in a repeated way. For example, you're training your deep learning model and you want to figure out exactly how long did it take to train the model. You can create a decorator for keeping track of time, and you just apply it with literally single line. Once you define the decorator, you literally have to put a single line before the function or a class, and then it just applies to your function. So let's jump in to get a good understanding. I hope you appreciated my my rudimentary editing of decorating a Christmas tree. And Python is like Christmas tree. So let's go ahead and decorate it. And like I said, I am going to share the code with you, so please pay attention to the video right now. And I added some text. And let's go through the text because I haven't created any slides like I normally do for this explanation. So first of all, a decorator, if you look at the definition online, it allows us to add new functionality to existing functions. Let's say you already defined a function, but you want that function to modify based on some conditions, then decorator definitely helps us. Hopefully this makes sense in the next 10-15 minutes by the time we end this video. And they allow us to wrap another function to extend the behavior of the wrapped function. So you have a wrapped function, and we want to extend the behavior of that by not modifying it, by not modifying this function. Okay, so this is another way of looking at decorators. And you call a decorator, like once you create a decorator, you call it by its name right before a different function. I know right now I'm using way too many functions, so it makes sense in a minute, hopefully. Okay, first of all, since we are talking about functions, let's understand exactly a few things that I'm pretty sure you know, but again, let's reinforce that message so we are all on the same page, and then let's move to decorators. So these are first-class objects in Python, and what does that mean? That means functions can be stored as a variable. You can just define a function and you can say a equals to that function. Okay, that's the first one. The next, you can pass an argument. You can pass one function as an argument to a different function. I'll show you very quick, simple examples in a minute. And you can define a function inside another function. This we know, right? I mean, nested functions. And you can return from another function. You can return a function. You can actually have a function as your return from a different function. And you can also store in data structures such as lists and so on. You can store these functions in these formats. So why am I talking about this? Because decorators leverage this behavior of functions. Okay, so let's move and start with step 0, I should say, which is, what is a function in Python? A function is where you define an operation inside the function, and you supply some arguments. Sometimes you don't have to supply arguments, and a function returns a value. So whenever you call the function, it's returning a value. So let's stick with simple example that most of us understand. Converting Fahrenheit to Celsius. I supply Fahrenheit and it gives me returns Celsius. So you see the input is Fahrenheit and here it's returning Celsius. And how does it convert that? The meat of the function is c equals f minus 32, or well, I didn't use 9/5, I just used 1.8, but that's close enough. This is the function, right? And when I call this, it returns the value, and the input here I'm giving is 90. So first let's define this function. This part I'm pretty sure all of you know. And let's call the function with a value of 90, and it gives me 32.22222. Yeah, that's a function. Now let's go through these one by one. Storing in a variable. So storing the function inside a variable. Let's define exactly the same function. So we have already defined it, but it's the same function. Now let's store that inside a variable called f to c. that's just a variable, equals to that function. So I'm storing that in a variable. Now I can, it's almost like the variable is my new function. So now I call my variable with an input of 90 and let's say the same value. If you don't give any input and you just print F2C, it's an object, right? I mean, if you just do that, it should return like, okay, this is basically an object. Yeah. So there you go. So this is the second part, the second point that we discussed here. Now let's define the third one. Passing a function as an argument to another function. What do we mean by that? Let's stick with the same example, Fahrenheit to Celsius. So same function again. Okay. Now let's define a function that calls another function, meaning I'm defining a function called temperature conversion, and the input to that is some function, whatever it is, some function, and then a variable called temp, which I set to 65. So and I added a print statement saying we are assigning f value to temp. Yeah, and then it returns that some function with temperature right there. I hope this makes sense to you, right? So this temperature conversion is basically taking in this, whatever the function I'm going to provide to it as input, and also temperature as input. And then it's returning that exact function I provided as input with a variable of temp as its argument. So let's go ahead and define this. And now let's define our temperature as 90, like we did earlier. And our converted temperature is call this temperature conversion function and provide this other function as the input, and temperature equals to this 90. I mean, you may think this is very simple and straightforward. Again, we are trying to make sure we understand the different things that functions can do and then get to the decorator part in a minute. So let's go ahead and run this converted temperature, and you should see that it is 32.22222 right there. So all we did is we defined our Fahrenheit function like normal. We defined another function and provided this as input to that. That's it. And returning this input function with a different, I mean, the function can do something in between. It can do a lot more things in between, right? We're just looking at the basics. Okay, the next behavior is that a function inside another function. This is a nested function we just talked about. For example, let's just define Fahrenheit to Kelvin. First, within that, I have another function called Fahrenheit to Celsius, which is the one we are familiar with. This is what we have done until now, right? So this part we just did 3 times. This function is completely inside the other. And once this C is returned, right there, yeah, now you can actually apply that to Fahrenheit to Celsius. We are calling that function right there with this F value. That means we get our C value right here, right? And now all I'm doing within the other parent function is just add the 273 to that, and it returns Kelvin. This is again pretty straightforward, as you can see. And let's do that for 90 degrees. Which should be 273 plus, oh, I'm not printing that. I should have added a print statement. You can see it is 305 degrees right there, Kelvin. Okay, so sorry about that. I should be a bit more prepared. Let's do that right now. Because I'm going to share the code with you, I just want to make sure in Kelvin is, let's go ahead, oh, sorry, and print this. I want to make sure this code is ready for sharing. Okay, 90 Fahrenheit in Kelvin is 305. Okay, so a function inside a function, nested functions. We have done this many times. If you are a regular viewer of this channel, you know that. And the next one, returning a function from another function, right? So let's look at that. So the primary function here is return Fahrenheit to Celsius function. Yeah, and then we have our famous Fahrenheit to Celsius in here, and this is basically returning that Fahrenheit to Celsius, this one, this function as part of this parent function. So when I call this return Fahrenheit to Celsius function, it does exactly that. It returns me whatever the function I have in here. Okay, so you can define a whole bunch of functions in here and then just add a return right there, and you can get all the functions. So let's run this one. And now my F2C function, Fahrenheit to Celsius function, is retrieved by calling this parent function right there. Okay, so right there, now I have my F2C function. So this F2C is basically a function right now, and I need to call it right there with a value of 32. I don't know why I changed from 90 to 32, but it's fun to see different numbers. So there you go. 32 Fahrenheit in Celsius is 0. We know that. Yeah. So what did we just learn? Returning a function from another function. So next one. This is just an extension. I mean, this was the last point, but I just want to make sure one other point here. The enclosed function right here, it can access the variables from the parent function. So for here, f, I'm not defining f explicitly right there. I think I did that. Here I did define f explicitly right there. Here I'm not defining it. I defined that in the parent function. So this one doesn't take anything as argument because it's getting it from the parent function, f. And then it calculates this. So this nested function has access to the arguments of the parent function. So let's go ahead and run this. And now when we run it with a value of 32, it returns this function with already a value of 32. So I just need to run this. So it just gives me 32 Fahrenheit in Celsius is 0. So it's returning that value right there. I hope so far so good. And most of this, I'm pretty sure you know that. So let's move on to decorators now. Okay, with this knowledge, now we can move on to decorators. So let's define pretty much the same thing, a decorator that converts Fahrenheit to Celsius. Okay, so first let's define our F to C decorator. A decorator is nothing but a function that actually has another function inside it. That's it. A decorator is a function with a nested function. Okay, so first let's call our decorator F to C decorator. And the other function, let's call it wrapper, that takes f as an argument. Okay, and I only have a bunch of print statements right there. And then I have a timing, start the timer, end the timer. Why do I have start the time, end the time? This is not going to take a long time to do this calculation. The reason I'm adding this is slowly I'm building a case towards just writing your own decorator to time a deep learning model. So I'm just subtly adding these things as we get there. And at the end of it, it says end minus start, which means it gives me the calculation time to convert my Fahrenheit to Celsius. But if you look at this, I did not define my function to convert Fahrenheit to Celsius. That doesn't matter because this decorator takes in a function as an argument, and then it does things in here. And you see this function, it's applied right there onto my f. And everything else in here, it doesn't matter. All it does matter is, okay, you have an argument right there and you have a function right here, which means I can apply this decorator to any function that takes in a single variable as input. I hope you appreciate that fact. And this is returning this function right there. It's returning the function. All the stuff that we just learned is applied here. Well, most of it is applied here. A nested function right there. And then the nested function is returning the wrapper right there. And then this is inside our decorator function. Now, how do we use it? So first, let's go ahead and run these lines. And now let's define our Fahrenheit to Celsius function that we know, right? This is the Fahrenheit to Celsius function. And the way you define this decorator is by putting an @ sign right there and followed by the decorator name. Our decorator name is F to C decorator. So that's it. And you put that right before your function. Then the function knows that, okay, there is a decorator and uses that decorator. What does that decorator do? In this case, that decorator prints a few lines and then also prints the calculated time end minus start. Since this calculation takes literally microseconds to do, I added 1 second of sleep time, so we'll see 1 point something. That's the only reason I just added that here. So I hope this makes sense. There is a decorator, and this is literally our, this is literally our function that we have been defining until now. So let us go ahead and define that. Now let's just call this function Fahrenheit to Celsius with a value of 32. I hope this makes sense now. The input value supplied is 32 and a line up here. Where is that coming from? It's this print statement The input value supplied is this. Above print statements from the decorator, above print statements from the decorator. Now entering the function, right? Now it enters the function right here. This gets executed. When this gets executed, it prints this line. That's why you see 32 Fahrenheit in Celsius is 0. This is from the function. And then the function gets exited. It goes back to the wrapper. And now these 3 lines are printed. Exited the function, lines, and calculation finished in. I hope this makes sense. We didn't do anything. We defined this decorator function once. And now no matter what function I have down here, I can just decorate it with this. Okay, let's keep looking. Another function, but the same decorator. I have the same decorator. I'm not writing it again. Another function. Now let's just say Celsius to Kelvin. Okay, the only requirement for this function is it takes one argument as input right there. That's it. That's exactly what I'm doing here. It takes C as input. So now we are doing Celsius to Kelvin. K equals to C plus 273. I added this time. You know why? And I'm printing this. Pretty much completely different function, let's say. And now let's run that new function with this decorator. So we should see the decorator doing its thing, the function doing its thing, and the decorator doing its thing. So you can see how if you have reusable needs, like whether it is timing is the easiest thing I can think of. There can be many things. Like for example, if you want to reuse a RGB to grayscale conversion or some sort of image processing operation before something else. If you want to do Gaussian smoothing, if you want to do denoising, just define all of those as decorators and just put at right there. That's it. And you're done. At denoising. Your image is denoised because it expects an image as an input. That's it, right? So whatever the function you have, there is an image as input. So these are some of the examples I can think of. But let's keep looking at a couple other examples. Another function here. Now here I showed you Fahrenheit to Celsius, Celsius to Kelvin, but let's do something completely different. It's not even conversion of one to the other. This is basically converting your lowercase text into uppercase text. Again, it takes one argument as, it takes like one input as argument. And then all it's doing is upper equals text.upper. Obviously, it's converting things into uppercase. And then it returns this uppercase. So let's decorate it with exactly the same decorator we defined. And then let's say our text, our input is hello from inside the function. And then let's go ahead and call this function right here. So let's do that. And there you go. You know that this part is coming from the decorator. This part is coming from the decorator. This part is coming from our function that actually takes this text and converts that into upper. So I hope now we reinforce the message of what decorators are used for and how they can be very helpful. So let's now go down to looking at a little bit more about decorators now with arbitrary arguments. So far we just defined a specific argument like, okay, it must take like one argument and so on. Now let's actually provide some arbitrary arguments. What do we mean by that? Let's do pretty much the same thing. Let's take our import time and let's just define a general purpose decorator. Okay, and within that decorator, I have another wrapper function that takes arguments as, you have your arguments right there and then keyword arguments right here, right? I mean, arguments are basically 90 or 50 or 60. I know I'm explaining the basics, but you never know who's watching these videos. Keyword arguments are, you just say f equal to 90, right? That's where you have a keyword argument. Please read more about those if you don't know what those are. But anyway, so you have a wrapper that takes arguments and keyword arguments as inputs. Now, I added a couple of statements here. The input positional arguments supplied are. So if you supply any arguments, then it prints it out. If you supply any keyword arguments, it prints that out. And I added a new line. And then my function that I'm going to define later on takes args or keyword args as inputs. This is so generic, right? I'm not defining anything. I'm not saying it's Fahrenheit. I'm not saying it's one argument. This can be many arguments as input. This can be one argument as input, many keyword arguments. But this is a generic purpose decorator that I'm defining here. What does it do? It prints these lines and then it gives me the total time it took to execute this. That's it. Whatever that function is, we are going to define it later. So let's run these lines here. Okay, and let's move on to a junk function. I wasn't being very creative, as you can see. A junk function where I just sleep for 1 second and I print I'm an empty function with no arguments. Sad. Okay, and I'm decorating that with my general purpose decorator. And as you can see, this function doesn't take any inputs, even though I defined that this function requires args and kw args. Remember, my previous decorator here, the function takes one argument right there, one specific argument. If you don't give that, it's going to throw an error. Here, we defined a generic star keyword arguments, right? So that's why I'm not giving any arguments right there. It's just printing. So let's go ahead and define this function. And when I call it, it should print from inside the function. So first of all, in the wrapper, I have these 2 lines. So it basically printed the input positional arguments are, we haven't supplied any. Keyword arguments, we haven't supplied any. And then it entered the function, which prints, I'm an empty function with no args, and then exited the function and the time right there. Let's take the same generic decorator and do something, let's take it to the next level, okay? So let's get back to our Fahrenheit to Celsius. What does this function take as an argument? Fahrenheit, right? And it returns Celsius. This is the function we looked at many times. Now let's decorate this with the general purpose decorator right there. That decorator just has a couple of print statements, including one that tells us how much time it took. So let's go ahead and run this. And now let's call this Fahrenheit to Celsius with a value of 90. We know it should be 32 point something. And you see here, the input positional arguments are 90. And we did not supply any keyword arguments. And 90 Fahrenheit in Celsius is 32 and blah, 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 all that. I hope you're slowly learning about the use of decorators. And I should admit, I don't use decorators as much as I should. I waste a lot of my time by writing these functions or copying functions from other code to some other place. In fact, the best thing to do is probably have like a library of all of these decorators and then just call them. So I don't have to write them over and over and over again. Yeah. Now let's use the same general purpose decorators, but with 3 inputs. Here it's only 1 input. Previously we saw 0 inputs. Now let's put 3 arguments. Not keyword, but regular arguments. All it does is it takes 3 numbers, 3 values, and then does some math and returns that. Okay, so let's go ahead and define this function and do some math. 2, 8, and 5, and there you go. Yeah, so my input positional arguments are 2, 8, and 5. We did not supply any keyword arguments. A plus B times C is 50 right there. Yeah, 8 plus 2, 10 times 5. So that's from the function right here, and remaining is the part of our decorator. Let's use general purpose decorator one final time with a combination of positional arguments and keyword arguments. So here, let's do Fahrenheit to Celsius with, I don't know why I put with name. Yeah, it gives you your name and then it's like, hey, John. So that's as creative as I get right there. Okay, so the input arguments are F, which is our positional argument, 1 keyword argument, which is name, another keyword argument, age 45. So it's taking our Fahrenheit, converting that to Celsius and comparing it to the age, and it's saying, hey, you're older or you're younger, whatever. It's pretty straightforward right there. So let's go ahead and define our general purpose. By the way, this decorator, we defined it once, way 5 minutes ago, and we are still using it in many, many different types of scenarios, right? So now let's call our F2C with name. Well, let's give 110 Fahrenheit, and name is David, age is 30. There you go. So the first 2 lines from the wrapper, and you see 110 is our positional argument, and the keyword arguments are name David and age 30, right? Name David, age 30. This tells you that my wrapper is looking at this, and it's let's not go forward. It's looking at my args and KW args, and then just returning exactly, printing what we supplied here. And this part, of course, is the main meat of the function. So it is actually printing out, hey, you are younger than the current temperature, which is 43 Celsius. Okay, so now one more topic. There is something called @wraps decorator. This can be very useful when you're defining your classes, when you're defining your functions, especially if you would like to construct your functions and classes such a way that you have very good documentation so others can read it, or if you're trying to create an API that others can easily look at, for example, by typing .help or something, then @wraps can be pretty useful. And it updates the wrapper function to look like wrapper function. You can read this. You can pause the video, read this, but let's look at things in action. So first of all, let's define our decorator. So decorator is it's very simple, as generic as it gets. All it does is it takes args or keyword arguments as input, and it takes a function, and then it returns the wrapper. That's it. There is nothing going on right there. So let's go ahead and define that. Now let's decorate our Fahrenheit to Celsius with that function, with that wrapper. So let's go ahead, and our Fahrenheit to Celsius, you know that this is F-32 or 1.8, and it's returning this. And if you look at this part, this is what you can retrieve by looking for docstring or looking for the help. If you don't know what I mean, then you'll know in a minute. But let's go ahead and decorate this function with my decorator right there. Okay, nothing happened. Let's go ahead and use the same decorator to decorate a different function, Fahrenheit to Kelvin. It's converting, you know, the formula right there, but I have again another piece of documentation there saying that, okay, F temperature in Fahrenheit, it returns temperature in Kelvin. Okay, very basic documentation right there. Now, when you do that, when you define these functions, how do you get this information by not opening up the code? I'm sure you know this, right? I mean, you just, whenever you import like some library or something, you go ahead and just type ._doc or help, let's say, some of these. So let's look at some of these. Like for example, let's call our Fahrenheit to Celsius _name. What is the name of that function? Fahrenheit to Celsius. What is the name of that function? It should be Fahrenheit to Celsius, but it's returning wrapper. It's returning this, because I'm decorating this with the wrapper. I hope this makes sense. What this is doing is wrong. That's what I'm trying to say. This is not what we want. We want this, when we call the name of a function, it should return the name of the function, not the name of the wrapper. That's one thing I wanted to show. And when you print the documentation for that, which is basically what's inside the quotes, when you do that for your Fahrenheit to Celsius, it's not doing that. It's not returning me this. Instead, it's returning me that. This is a wrapper function. Again, wrong. We don't want that. So when you decorate something, a function, yeah, then what's happening is when you're actually calling it, it is returning the values for the decorator. So this is exactly where the @wraps fits in. Okay, so let's come down here and redefine our my decorator, the empty one that does nothing. It only has this docstring, that's it. Okay, so let's go ahead and run this. And now here, exactly the same function, except I'm going to decorate that wrapper with another decorator, which is the wraps in our case, right? @wraps function right there. So let's go ahead and run that. And there you go. So this is, again, this function, my decorator with wraps, is exactly like my decorator, except before the wrapper function, I added this decorator called wraps. And this is going to help us in retrieve the relevant docstrings and other information. Okay, so let's go ahead and test that. So my decorator with wraps, instead of my decorator, now I'm decorating this with wraps. We already saw the one without just a minute ago. So let's run this and also this. So these functions are the same. Yeah, these ones are the same. It's just that I'm decorating it with something else that has the wrapper. Okay, so it's saying wraps is not defined @wraps function. I thought I have defined it. My apologies. So let's see if we have defined this wraps anywhere or if we forgot to define that. So let me not waste your time. Let me pause this video, check, go through all these lines of code to make sure we haven't skipped a line. So just a second, I'll be back. Okay, sorry guys, I just realized that I totally forgot to import wraps, and that's why it's throwing that error. So all we need to do is from function tools or func tools import wraps. Okay, key point, and again my apologies for not testing this out, and I should have tested the code before recording the video, but I'm confident that this works, so don't worry about it. Well, we'll see if we have to worry about it. So let's run this one more time. So there you go. So at wraps, so I'm actually decorating this with the wraps right there. And now let's do this one more time, and hopefully it shouldn't throw anything, any errors. And I'm decorating this Fahrenheit to Kelvin again with my decorator with wraps. Yeah. So let's go ahead and do that. Now let's run exactly the same thing right here, Fahrenheit to Celsius underscore name. And when you do that, hopefully it returns the right function right now. Previously, it was returning the wrapper because this function was wrapped inside another function. And when I say give me the name of the function, it was giving me the name of this parent function and not the actual function I'm calling. And at wraps function, by decorating this wrapper with that, addressed that specific issue. That's it. Okay, that's the summary of the story. Same with the docstring. If you want to access the docstring inside this, now you see Fahrenheit to Celsius, it's giving us this information right there. Okay, so now let's look at again a couple of examples. Again, it may sound like I'm doing this video for a long time, but I want to make sure everything about this decorators is captured. At least most of it is captured, so you can go ahead and explore this on different, be creative. Try to apply this to different types of functions. So let's go ahead and define pretty much the same thing. Now we don't need a decorator without wraps. In fact, I never use that. I always use a decorator with wraps. So let's go ahead and do that one more time. We have already done that before, but now just for the sake of completeness. Okay, so let's define, this is how you properly define a class, right? I mean, previously I showed you the same decorator on individual functions, but it does make sense for us to have a class that converts temperatures and then different functions within a class. So that's exactly what I'm trying to do now. So I'm defining a class called convert temperature, and I have some docstring for that class. It says, okay, this is a class that converts F to C or K and blah, blah, blah. Within that, I have my init function, of course, and then I have my docstring right there, and then I have my Fahrenheit to Celsius, and then I have Fahrenheit to Kelvin functions defined. And for each of these, I have obviously respective docstrings. So this is just an example of showing how you can use the same decorator with wraps for a class, not just for a function. So any object, it works. So let's see, and I have Fahrenheit to Kelvin and returning that, so that's good. Let's run all of these, which is basically creating our class right there. And now let's go ahead and convert temperature, right? So what is my convert temperature? Convert temperature is the class name. So let's go ahead and do class name.help. This is how you typically access the docstring, right? So help, sorry, not .help, help convert temperature. So let's go ahead and type that, and it gives you all the information about that specific class, convert temperature. This is a class that converts all the stuff that we just defined here. Okay, again, we can get that because we are using that wraps as part of our decorator with wraps. Now you can access the docstring for a function or a method inside your class right there. So Fahrenheit to Celsius, previously it was the class. Now let's go ahead and look at the actual Fahrenheit to Celsius function, and this is the function to convert that. So you can see how these things can fit together, and you can see why these things can be very helpful when you're trying to write code that you want to give it to someone else, or do you want to share, almost like an API type of interface environment right there, or documentation, I should say, sorry. Now, the next part is let's just look at some practical example, which is exactly what I mentioned at the beginning of this entire video, which is just use it for timing. Yeah. So we are going to define a function called execution time. This is our decorator. Forgot what. Anyway, execution time is our decorator, and then we have our wraps. Yeah, as usual. And our wrapper has arguments, any number, or keyword arguments, any number. We don't know. It just has these arguments. And what does the wrapper do? It just starts the timer and then ends the timer and gives me end minus start. That's what this wrapper does. In between, it's going to apply the function onto your arguments and keyword arguments, and whatever the result is, it's going to return that result. And of course, wrapper, we are returning that wrapper right there and to our main function, and we're good. So this is what this wrapper does right there. Okay. And now let's decorate, just doing some math with this. Again, I added 1 second sleeper time just because these calculations are pretty fast, and we'd probably see 0 if I don't add 1 second time right there. So do some math at execution time, and let's run that function. And when I call that function, it is returning us the total time for execution is this. Of course, it's doing that from the function, but then these two, function name is and the total time for execution, are returned from my decorator. And how did I call that? Just using a single line right there. Your decorators can be in a different file. You just import them. Okay. Now what? Let's just look at a practical use of just a deep learning, not that deep. We'll just see a couple of dense layers. Let's train it and apply this execution time wrapper to the training time and also the predicting time, and then just see how that looks like, the entire thing looks like. So this function is exactly the same as before. Or the wrapper, or the decorator is exactly the same. What does it do? It gives me whatever the function name is and the total time for execution of that specific function. That's it. Now let's apply that to a real case, well, not a real case, but some deep learning based data set. So this is Pima Indians Diabetes CSV file, and I can leave a link to this data set, but it doesn't matter. You probably have your own favorite deep learning algorithm anyway, but if you want this, I can leave the link. So let's go ahead and import our Keras sequential method so we can create our model, and let's go ahead and load the data set. This one is, where is it? Indian database not found. Okay. So what that means is I'm probably not in the right working directory. So yeah, so I'm in a different directory from my other work. So let's go ahead and, where is this? It's in Decorators, right? So sorry, I put some zeros behind this. Okay, Decorators. Okay. So let's see. Okay, I'm in the right directory now. Sorry about that again. Lack of preparedness, but now we have our data set, and we have 768 data points and then 9 columns. Of those, the first 8 columns are used for training, and the last column is used for prediction. So let's go ahead and define that. And now let's define our model as sequential, and there you go. It's a binary case. 0 or 1 is the output. That's why I'm using 1 right there, and sigmoid. Now let's compile the model and print the summary of the model. This is your typical deep learning. So we only have not that deep, obviously, 221 parameters. Let's go ahead and fit it for 10 epochs. And this is how you typically do it, right? So it's firing up my GPU and all that. So there you go, 10 epochs, it's done. Now, how do I know how much time it actually took to do that? I can actually add start time here, end time here, and then do end minus start. Nothing wrong with that, but I have to do that many times. If I want to time the prediction, then I have to put start and end. I'm going to add an execution time decorator, which is what we defined up here, to my fit model function, which is basically model.fit. That's it. So when I do that, now I need to call that function, and now it should do exactly the same, except at the end, it prints total time for execution is 2.38 seconds. I hope you appreciate this, the simplicity of this. And I defined this once, so I can use it many, many times. I'm using exactly the same execution time, but this time, see here, the function was fit model. Now this time the function would be predict on training data. So let's go ahead and run that function and then predict on training data, and prediction equals to, oh, I did not put any, let's see, maybe I did not include the execution time when I defined the function. So let's do this one more time and predict. There you go. You saw the result without using the decorator and with using the decorator. Without that, there was nothing. I mean, we got no result. And now we have our result as the total time for execution, 0.08 seconds in this case. Okay, I think this is, I know this is a very long video on a topic like decorators, but this can be a bit of a tricky topic for most of us to grasp. But once you understand this, you can see how powerful this can be. So I really hope you're patient. I mean, appreciate your patience, and I hope you liked this video. And you found this to be educational. If so, please hit the like button. I'll do more such videos if I know that many people are benefiting from these type of videos. Thank you guys, and again, let's meet in the next tutorial.